Yesterday, we started the area between the curves. We will continue with examples. Today's example will be a little bit more complicated. Find the area enclosed by y equals 4 over x, y equals 16x, and y equals 1 over 16x. X is greater than 0. We have 3 curves, and we want to figure out the area enclosed by 3 curves. This looks like a 1 over x, but there is 4, so probably it changes a little bit faster, but general graphical shape should be identical to 1 over x. When x gets larger and larger, y value becomes smaller and smaller. This graph is y equals 4 over x. If you look at these 2 functions, then those are linear functions. This slope is larger and this slope is smaller. And there is no added term. That means it passes through the origin. So we will just draw the steeper straight line. That is y equals 16x. The other graph will be like this, which is slow growing. So y equals 1 over 16x. What the problem is asking you is figuring out area enclosed by these 3 curves. When we try to figure out the area between curves, what we did was we subtracted the smaller graph in the region from the larger graph. But 3 graphs are involved. And if you look at the picture, then when you look at this part, 2 straight lines are involved. But if you go further, then at a certain point, this curve and 1 straight line is involved. So we have to subdivide the region into 2 different regions. Let's draw the vertical line here. And let's denote this region as A1 and this region as A2. So what we have to do will be, we have to figure out this point and we have to figure out this point by calculating the intersection point. In this region, these 2 graphs are involved. So at the intersection point, y values must be the same. So we put the equation 4 over x equals 16x. And then we multiply by x on both sides. Then we have 4 equals 16x squared. So x squared equals 16 over 4, which is 4. We divide by 4 on both sides. So x becomes plus or minus, it is a 4 over 16. So that is 1 over 4. So it becomes 1 over 2 or minus 1 over 2, but we are thinking about the positive part. So this is 1 over 2. And then we have to calculate the intersection between this curve and this curve. So we make these two equations equal. So 4 over x equals 1 over 16x. So we multiply by x on both sides. So 4 equals 1 over 16x squared. And then we multiply by 16 on both sides. So x squared equals 64. So x equals plus 8 or minus 8, but this is positive number, so we get 8 here. Now we want to calculate the area A1. A1 start from 0 and go up to 1 over 2. So 0 to 1 over 2. In that region, this straight line is larger than this straight line. Its slope is larger. So 16x minus 1 over 16x dx. And then we do term by term integration. So 16 x to the 1 power, so x squared over 2 minus 1 over 16 times x to the 1 power, which is x squared over 2. From 0 to 1 over 2. So this is 8x squared minus 1 over 32x squared from 0 to 1 over 2. The remaining step will be pretty mechanical. So that is 8 times 1 over 4. We plug in 1 over 2 minus 1 over 32 times 1 over 4. If you plug in 0 here, then those terms will vanish. So we don't have to think about that. So that is 2 for the first one. And the second one is 1 over 128. You can use your calculator if you want. 2 is 256 over 128. And if you subtract 1, then you will get 255 over 128. Let's calculate the area 2. Then we have to integrate from 1/2 to 8. In this region, this curve is larger than this straight line. So we will subtract the straight line from 4/x. So 4/x minus 1/16x dx. Integration of 1/x dx equals natural log of absolute value of x plus c. So we will use that formula. So that is 4 times natural log of absolute value of x minus 1/16 times, this is 1 power, so x squared over 2, from 1/2 to 8. Now we will put the number. So natural log of 4 times natural log of 8 minus natural log of 1/2 minus 1/32 for digit 2. 8 times 8 will make 64 minus 1/2 times 1/2 will make 1/4. We want to simplify a little bit by using the logarithmic formula. Before we get to there, let me review the logarithmic formula. Natural log of A plus natural log of B was the same as natural log of AB. And n times natural log of A equals natural log of A to the n power. And this is just a power formula, not natural log formula. A to the n power is A to the m times n power. So the first thing we want to do in this situation is observing minus natural log of 1/2 can be written as minus natural log of 2 to the minus 1 power. And then by this logarithmic formula, this minus is minus 1 times this. And so that equals natural log of minus 2 to the minus 1 power. And we raise that as power here. And then we apply this formula. Then minus 1 times minus 1 will make 1. So that becomes natural log of 2. So this part can be written as natural log of 2. So 4 times natural log of 8 plus natural log of 2 minus 1/32 times 4 is the common denominator because 64 is 64/1. If you multiply by 4, then you will get 256 minus 1. And then to conclude the problem, what we have to do will be, we will combine these two. These are addition form with the same logarithmic base. So we have to multiply to put things together. So 4 times natural log of 8 times 2, which is 16, minus, if you multiply these two, you will get 128 and 1 less 255, right? Here we calculated the area A1 and area A2. All we have to do is adding up A1 plus A2. A1 is 255 over 128 plus A2 is 4 times natural log of 16 minus 255 over 128. The two will cancel each other and we get 4 times natural log of 16. Any question about this problem? The next problem is find the area of the region. Bounded by y equals 4x squared. The tangent line to this parabola at the point 5 and 100 and the x-axis. This is a similar pattern of the problem. However, one of the equation is hidden here. So we have to get the equation of the tangent line. If we visualize the circumstance, it looks like this. This is a parabola which opens up and passing through 0. This is y equals 4x squared. And they're talking about the parabola at 5 and 100. The tangent line of the parabola. This is the tangent line. This intersection point is 5 and 100. This is the point this straight line passes, and we have to know the slope of the straight line. The slope of the straight line is the derivative at 5, x equals 5. So that is 4 times 2x equals 8x at 5. Then that is 40. So this is the slope of this line. Point slope form in the linear equation is y minus y value it passes. So minus 100 equals 40, which is a slope times x minus x value it passes. So that is 5. So that is y minus 100 equals 40, x minus 200, and we add 100 on both sides. So y equals 40, x minus 100. So we got the equation of this straight line. And then we have to figure out this region, the area of that region. If we do the same thing, which we did in the previous question, then you will try to put the vertical line here, and then you will get the x-intercept, and you will divide that, the area, into A1 and A2, like this. And then you will calculate this region and this region separately. However, this is also the correct approach, but we will take the different approach. If we see the graph a little bit differently, then we realize that if we just look at this way, and we think about horizontal rectangles, then only two curves are involved, and you don't have to divide the region into two subregions. But if we place the rectangle horizontally here, then this vertical line becomes delta y. So integration will be like the y value range and dy, right? And if we look at this way, then you can see this straight line is larger because x values are larger, and this parabola is smaller. So y value ranges from 0 to 100 because this is given. Integration 0 to 100. I said the straight line is larger. So straight line is larger, and what we know is this is the y related terms because we are thinking about the variable y. So for this one, this is y equals 40x minus 100. However, we have to solve for x to make this as x equals something to do with y. So y plus 100 equals 40x, and we divide by 40 on both sides. Then that becomes x equals y over 40 plus 100 over 40, and that is 2.5. So x equals y over 40 plus 2.5. And for this one, we have to solve for x. So this becomes x squared equals y over 4, and then x equals square root of y over 2 or minus square root of y over 2. However, we are thinking about right half side of the parabola. So we will choose this one. So we will use these two equations. I said this one is larger, as you can see here, than this parabola. So we will put y over 40 plus 2.5, which is the equation of the straight line, minus square root of y over 2 dy. Then we have to do term by term integration. 1 over 40 times this one is y to the 1 power, so y squared over 2 plus constant terms integration is constant times x. In this case, y. 2.5y minus 1 over 2, which comes from here. And y is 1 over 2 power. Square root of y is 1 over 2 power. And 1 over 2 plus 1 is 1 over 1, which is 2 over 2. So that is 3 over 2. And then when we integrate y to the 1/2 power, this one will be y to the 3 over 2 power over 3 over 2 power. And this is in the denominator. And so we can flip it and write in front of the numerator. That came from this one, a times 1 over b. So this one stays the same. And if you multiply these two together, then denominator should be multiplied with the reciprocal. So it becomes 2 over 3. So times 2 over 3, y to the 3 over 2 from 0 to 100. Any questions so far? Let's evaluate. Then it is 1 over 80 times 100 squared plus 2.5 times 100 minus 1 over 3 times 103 over 2 power. And then minus, if you plug in 0 here, then all the terms will vanish. And so we don't have to go further. Now, let's think about 103 over 2 power. So 10 squared times 3 over 2. So if we multiply the 2, then the 2 and 2 will cancel each other. So we have 10 cubed, which is 1,000. For this part, 100 squared is 10,000 over 80 plus 2.5 times 100 is 250 minus 1,000 over 3. So if you use your calculator, then that'll be 125 plus 250 minus 1,000 over 3. That is 355 minus 1,000 over 3. You can use calculator, then you will get 125 over 3. For this part, if you can use your calculator to get 125 over 3. Any question? That is the end of sections 6.1. 6.2 is about volumes. The method I will introduce to you will be cold washers method or disk method. Before we talk about volumes, let's talk about the volume of cylinder. Cylinder look like this. Then you can calculate the area of the bottom. And this is the length. Then the volume is A, area of the bottom times the length, A times L. What we want to think about is formulating the three-dimensional object, which is a volume rather than area. When we have a three-dimensional objects, we still dissect the object vertically like this. When we think about the area under the curve, what we did was we thought about the region and we drew the sticks like this. This time we have an object which is a volume. So we slice the object vertically like this. Then small slices will be will look like a cylinder. So let's think about this cylinder. Then, and we think about the region, this volume. A to B. If this slice is small enough, then that resembles the cylinder. So it looks like this. And let's say the random point in the middle is xi star. And let's say this is xi minus 1, and this one is xi. Then we are slicing things vertically, and so this thickness can be described as the delta x, and we will slice this region with infinitely many vertical sectors. When we focus on this cylinder, when that is xi star, This part has an area. Area is A. Let's denote that as A of xi star. Then what we can say about this part is the volume is A of xi star times delta x. So the volume can be calculated by adding all of those cylinders' volume. And eventually, those sum will approach the actual volume when we dissect this region vertically with infinitely many cylinders. That can be expressed as limit n goes to infinity, summation I equals 1 to n, A of xi star delta x, so one cylinder's volume. And then as we did when we defined the area of the under the curve with integration notation, we use integration notation because that is limit n goes to infinity summation. So stretches sum. We are thinking about A to B. So A to B, lower bound and upper bound. And this part can be written as A of x, and delta x becomes dx in the notation. That just means this length is extremely thin, almost to zero. So this is the formula for the volume of the object, three-dimensional object. And I will start the example tomorrow about obtaining the volume of the object. We will think about the disk method, which means we will rotate the object along the straight line. And then we will calculate the volume. Do you have any question? If you have any question, then you can remain and continue to ask me question. If you don't, then you can leave.